Welcome back. In the previous step, we looked at the basics of abstract class. In this step, let's look at a real world example of how you can use an abstract class. I'll create a new Python file. So let's create a new Python file and I'll call this recipe and say okay. Typically, whenever we cook something, there are typically three steps involved. First one is to prepare, right? So you'd want to make sure that you have all the raw materials ready, and you'd want to make sure that you have clean vessels, the dishes are done and ready for use. The second one is to execute the recipe, right? So you'd want to make sure that you follow the instructions, do the stuff, and the last step is to do a cleanup. Make sure that you garnish. Probably you'd want to make sure that you put it in the proper vessels and things like that. These are three steps that you would need to do whenever you do a recipe. Let's say now you're creating a class to represent a recipe, and you want to make sure that each of the subclasses follow these three things. How do we do that? One of the solutions that we can use is to use a abstract class. Let's import the abstract class stuff. So from ABC import ABC comma abstract method. Now let's create the class abstract recipe, and we would want to ensure that it extends ABC abstract base class, and we would want to create a method in here what we would want to call as def execute. So execute is executing the entire thing, doing the prepare, doing recipe and doing cleanup. What we can do is self.prepare, self.recipe and self.cleanup. However, this is just the abstract class, so we don't really know what the exact preparation is. The exact preparation depends on the specific thing that we are actually doing. Let me fix a typo in here. So it's abstract recipe. And so what we would do is we'd make prepare, recipe and cleanup abstract methods. How do we make it abstract methods? You would add a decorator called abstract method, and we would say def prepare is pass. And let's do the same thing for the other methods. So what we are saying is we don't know what are the steps which are involved in the preparation. We don't know what are the steps involved in the recipe. We don't know what are the steps involved in cleanup. But we would want to ensure that these three steps are defined by all the subclasses. And when we execute something, we would want to follow these three steps in order. What we are defining is the algorithm, and we are leaving the implementation of individual steps to the subclasses. This design pattern is also called a template method design pattern. What we are doing is we are preparing a template method. We are saying this is the template we would want to execute. However, the steps can be defined by the individual subclasses. Go ahead and now try to create an instance of the abstract recipe. Would that be allowed? What would you get? Obviously cannot instantiate an abstract recipe because it contains abstract methods, right? So we would want to create a real recipe, let's say. What we can do is we can say recipe 1, and I'd want to extend the abstract recipe class, and over here I can define these three methods. So let's go ahead and define them. So these are no longer abstract methods, and I can define instead of doing a pass. So I would want to say print do the dishes. So as part of the preparation, I would do the dishes and get raw materials. And the recipe, let's just say we execute it. Print execute the steps. Oops, I did not remove the pass, that's why it's complaining. And now cleanup, I would want to really leave it empty for now. So what would happen if I do recipe 1 I create an instance of it and dot execute. What would happen? It says do the dishes, get raw materials, execute these steps. So what we are doing in here is the abstract recipe acts as a template. This execute method acts as a template. It ensures that all the subclasses follow these steps. We have a preparation step, we have a recipe step, and we have a cleanup step. It ensures that all the subclasses follow them and create definitions for those methods, and the execute method would execute all of them. We can create another example. Let's say we would want to create a microwave recipe. So a recipe where a microwave is involved. So let's say the first one is to get raw materials, do the dishes, get raw materials, and the third step is switch on microwave. The recipe remains the same, and during the cleanup what I'll do is I'll do a switch off microwave. Now I'll try and create an instance of the microwave recipe. Let's leave a new line in here and run this. You can see that now the recipe is executed according to the code which we wrote in the microwave recipe. So do the dishes, get raw materials, switch on the microwave. After that, execute the steps and then switch off the microwave. Abstract methods play a key role in defining a template method and making sure that all the subclass methods define all the abstract methods. This is a very good example of a design pattern which depends on abstract classes. This design pattern is also called a template method because we are defining a template method which is followed by all the subclasses. In this step, we looked at an example of an abstract class and how it is really useful in designing your code. I'll see you in the next step. Until then, bye-bye.